Welcome back to Made Up of Wires, where I am distracted. And we are going to do some decompilation of Castlevania Symphony of the Night in 1 second. If you haven't watched the stream before, you can go to soten.z.dev to learn more. We spent some time decompiling Castlevania Symphony of the Night and talking about various decompilation things. What I've been working on more recently is trying to actually write a pseudo spec, maybe even a real spec for identifiers that can be used across different platforms for figuring out functions that might be shared or things like that. I've talked about the MIPS match project in the past, and it has to do with that, but kind of formalizing the output of MIPS match so that it can be used by other systems, including Decomp.me and others. And the idea is that we have some unique values that can describe a discrete section of code without including any of that code or even necessarily where it came from. And the goal there is instead of having, say, a UUID, which means nothing to a particular scratch, or a incrementing identifier or randomly generated identifier, or even a cryptographic block hash, that we can use something that can both uniquely identify the section of code that was uploaded, but also give you the ability to find that section of code in opaque binaries that you may get. And so, for example, this top one here came from, I believe, no, these are examples of code that I wrote, but we're currently using this in make config, not these particular hashes, but this process to generate what I'm calling fingerprints of code that we have already decompiled, so that we can then find that when we get new overlays, we can find that code if it exists and give those symbols and maybe determine where splits are, things like that. So anyway, I'm trying to formalize this. I was talking to Ethan of Splat fame about this, and maybe it's something that we can figure out, something that both works for what we're doing in Soten Decomp, but maybe a lot of other projects as well. And the idea that I have with Decomp.me specifically is that if these particular identifiers are searchable, things like families could be immediately grouped. You could also determine almost immediately when something has already been decompiled by calculating that hash. And like I mentioned, the big thing over, they could use cryptographic hashes for that same thing, but if they did, that cryptographic hash can't be used to search in other files, because you need more than just the hash. You need to know the size, and then you need a way to find it as well. The way MIPS match finds things is by a relatively cheap linear search. If you have something like an MD5 hash of a particular code, you get a very expensive process where you have to basically take 4-byte increments through some window, assuming you know the size, and then calculate an MD5 for every increment throughout the file. And that, if you have a multi-meg file or multi-gig file, that could be very expensive. Whereas MIPS match, you just have to scan through once and then it's done. You find it or you don't. All right, let's get back. So we were working on NZ1. NZ1 is the clock tower. And I'm not going to go to decomp.me right away this morning. Let me make sure that I'm in the right branch. I am. What I want to do is finish off the Cloak Knight work, and what needs to be done for that is naming some symbols, getting the entity extensions done, and so you may or may not think that this is as exciting as finding something new, but it's a necessary and essential step for sharing our work, and having a sustainable and usable project. Let me find where my tab is. It looks like I have this one. There we go. Too many things open, like usual. So I was looking at that data to make sure that we have everything. So I built all. What I'm going to do, I'm going to move nt1.h out of the way. We're probably going to be mostly working through the Cloak Knight sword, and maybe a few other entity extensions that exist. I've talked about it before, but just as a refresher, most things in Symphony of the Night we describe as an entity. Anything that you can interact with is an entity, and you can have up to 256 of these active at any time in the game. That's a fixed upper limit. And what does it mean to be active? It may mean on screen, it may mean something off screen, but being tracked. It's each entity exists and is primarily responsible for the things that you see on screen, but an entity can exist that represents nothing that you see, but maybe some behavior that needs to take place in the background. Anything that is drawn, those polygons typically are associated with an entity, but a entity could have multiple polygons, and the polygons are used for sprites and everything too, so they can be 3D, they can be 2D, and it contains the business logic or behavior. I say business logic, game logic for that particular thing. So we're going to look at the entity struct, and the entity struct has all the common fields that all of those things need. Not every entity uses all the fields, and not every entity needs them all, but they're mostly common thing. And then in kind of in the middle here, towards the end, we used to have this 8b actually as part of the entity extension, but it seems to be used universally enough and never used for anything else. We have what we call the entity extension, and that is quite a few bytes. If I could do math off the top of my head, let's see, we have BC. B is 11 minus 7, so that's 40 in hex, so 64 bytes that the entity can do whatever it wants with. And each entity type often has its own unique layout, and so we call that the entity extension. We have a huge union with over 100 of these now, maybe approaching 200, who knows, a big number. Let's see, how far does this go? Yeah, it is over, it's about 300, so 3915 all the way up to 3606. So we have 300 different uses for this at the moment. Some of these probably can be consolidated. How you consolidate a particular entity extension, so we probably should write a script to figure out when and how those overlap, and if you get it wrong, it's pretty painful, and if you don't do it, we get an explosion like this of extensions as well. So screwed if you do, screwed if you don't, but that's what we're doing for the Cloak Knight and Cloak Knight Sword, and maybe Cloak Knight Cloak. I think it has its own as well. Somebody much smarter than me came up with this idea of the illegal placeholder. So a long time ago, how long ago? Sometime last year. Let's did illegal come about? Let's look at a git blame. And we want 3607. Last year, so just over a year ago, Bismurphy looks like checked that in. And there are some wiki pages still, I think, about the ET generic. And what was happening was, let's go find that. There was basically just this blob, and that blob could be anything. You had to cast it to what you wanted, and it wasn't super scalable. And so what the illegal placeholder did was immediately identify that the entity extension, the correct entity extension, hadn't been found yet, but also gave M2C a structure that it could look into and basically calculate correct offsets for all the types, and whatever offset that it needed into that structure. So it kind of served two purposes, and it was pretty nice. And now, for the most part, everything has an entity extension that works with it, and that's what we're doing today, is creating some more custom entity extensions that are going to help us produce maintainable code. The other thing is, if you're doing a code review on any of this code, you see illegal, and then you know to flag that immediately because it should be fixed. So we're in Cloak Knight. Everything that, if we're operating on the self arg here, everything in its extension should be part of the Cloak Knight entity extension. And so we need to figure out two things. What is the stride? The stride is an assigned 16, which is 2 bytes at a time. And we're at offset 13 hex, which is 19 decimal, into that. And so we can multiply 19 times 2 and add 7c, or, since I'm doing this in hex, 13 times 2 plus 7c. That gets us to A2, and we have unknown A2 already. So any, I'm just going to do maybe not a full search and replace. The reason I don't want to do a full search and replace is in case there are other entity extensions where this doesn't make sense. But I'll replace this with unknown A2. And I will do, actually, let's go back to that. I will do a search for that, though. And that way we can go through and find it. And then in my copy buffer, I will put, make sure this works. I will put this field in, and then we'll go do as many of those replacements as we can. Hey, roaming, how's it going? Oh, and that didn't work. And so we got to figure out what was the matter. What did I do wrong? So the PSP wasn't happy with that, and we are getting... Let's try it again. Let me make sure I did the math correctly. So we have x13 times 2 plus 7c. That gives me A2. Let's try it one more time. Cloak Knight, A2. Interesting. So let's see what the problem is. So I'm expecting A2, but I'm getting A6. So it looks like I did my math poorly, and that means any unknown A2s that I already have, which I don't have any, are wrong. So let's see where I screwed up my math over here. Pause is being used, so I know that that offset is correct. It looks like I'm 4 bytes off. Is 9E being used? I know 9E. I know 9E is not being used yet, so it also may not be correct. Oh. Let's see. 9094, 98, starting at 9C, and this should be 9E. 2 more is A0, and then 2 more is A2. So what the pause is size 8. Oh, thank you. Appreciate it, roaming. That's exactly right. So let's put that back and try again. And this is one of the more difficult things about dealing with entities. Everything, for the most part, includes game.h, which is where entity is defined, and so every time you change your entity, you have to recompile effectively everything. And that worked. Thank you. Appreciate it, Romy. All right, so now we do have a working offset. And we'll go make sure that I'm still in Cloak Knight. I should be. I don't think anything else outside of Cloak Knight is going to have data that far in the entity extension. A2 is pretty far, and so we'll see if any of these other fields get pulled in. It could also be that this is shared with another entity, and maybe a bunch of these are merged into a single struct, but we don't know that. And so if we had names for these, we might be able to figure out what that struct is. I don't know if this is in my copy buffer anymore, so I'm just going to do it like that. And subsequent builds will be cheaper. The whole ext, I don't remember. Grab the dot. And so even though this is not the nicest name, unknown A2, it's slightly nicer than illegal. And let's confirm that that all worked, and that's good. And so now we know unknown 11 as well, which is going to be unknown 9E. So giving this a name like rotate might, so this is like I guess how much we're rotating each time, it looks like. So we can make a comment over there. I have to be very careful because if I save this file, and I'm going to rebuild everything, so I'm going to wait to save it until I get some structural change there. All right, let's find all those. We have one that's a little bit earlier, step towards. That might be the target distance. Let's make sure that's working everywhere. Didn't expect much different. Let's look at that step towards. Yeah, so we do have the second arc to step towards is one field earlier. And I do have that listed as target. So I am going to this looks like it's the target angle. Or target distance. This is being calculated as distance here. So let's name that target distance. I think that's safe to do. I like using bit fields when I'm padding out structs. So in the past, people would put pad arrays or other things like that, or just, pad 0, pad 1, pad 2. To me, I want to program in a way that reduces the likelihood that I'm going to screw anything up. And so an offset into an array, an accidental offset or off by 1, off by 2, or just even the noise of the pad fields. Having an anonymous bit field like this makes it so that none of that is addressable. And so I don't use an editor with field completion or anything like that. But if I did, you can't screw up by choosing the wrong field there. So that's what that notation is, and that's why I use it. I've done that kind of for years for non-decomp stuff, and I think it works pretty well. I'll call this one target distance, and so now we will have to rebuild everything. And I'm going to do one more while I'm here. Looking at this S16-2. This looks like a timer. A timer for what? I don't know. Do we have any more of these? What I want to see is how many of these do we have, and can I just call this timer? We at least have one more that is 12 bytes in. Oh, isn't this pause? This is the first field of pause, so that's not a timer then. So everything else, I think I'm just going to call that timer, since we're so in offset 80 here, we're gonna have assigned 16. I'm going to call it timer, and then we need to pad out 82 as well. And I'm not going to put that one in yet. I'm going to stick with the target distance, and then I'll come back and do that. But let's rebuild all and see how it goes. Good call on the size 8. I probably would have stared at that for a while. Let's go. All right. So now we can go to, let's keep looking for those. Get rid of all those not timer. Sorry, not the 11. We want offset 2. And oh, I didn't finish target distance. Target distance was offset 10. No, that was the only one. Other one? Well, okay. Make sure I didn't screw it up. And then we'll look for the offset 2. I think this would be less error prone in decomp.me and a little more forgiving. You can see immediately when you screwed up. I'm gonna screw up one of these base conversions. Not yet. You haven't gotten me yet. Hexadecimal. Oh, screw that up. But I feel like the overhead of switching back and forth is a little higher than I want. Okay, make sure all those look good, and then find the next one. So we have a... Make sure we're still in Cloak Knight. We are. So we have offset C, which, as I mentioned, was the position. Let me grab the... So this is a fixed 32, and a fixed 32 has a high-low or a val. 60 bits. Oh, pause is only... No, it is 32. Yeah. I'm done. So here we want pause, Cloak Knight, pause, X val. Oh, it was signed 16, so we want XI. XI low? Nope. What am I missing? I would have assumed it's XI high. Let's build and see what I draw. It wants 9.4 and I have 8A. Calculated that wrong? Oh yes, I calculated wrong because I added C and I didn't double it. That was my problem. C times 2 plus 7C. I can type 94. We don't have one for that yet. Let's see what else we have, if there's anything I have. Unsigned 16 at offset 4. Don't have one there either. So our unsigned 16 at offset 4 is going to be here at 84. So that's 4 times 2 plus 7C is 84. Yeah, just confirming. So we have an unsigned 16 there. It turns out that I have a conflict, so I'm going to cut it short. We'll get back to this. I'll probably be on tomorrow. But I will catch you all tomorrow. We're decompiling Castlevania Symphony of the Night. If you want to know more, go to swin.z.dev. Adios.